And we're back online. Okay, good. All right, so I think we were trying to open that BMI file. BMI, insulin sensitivity. Oops, I can't get to that now. And see if I can get SPSS to start up this time. And let me go back to my folder here. And I think this time it will start up. Bounce, bounce, bounce. We had a number of questions about reformatting data and so on and so forth. I'm going to actually try and go through a number of examples so that we can actually see how that works out. And as soon as I get done with the correlation regression, we'll get Zoran up. He's got 5 minutes. He'll do his presentation, and then we'll critique it, and we'll go on and we'll actually look at some data sets, including perhaps his, so we can decide on how he coded it, how we might, other ways we might code it, and so on. And hopefully, did we start here? Oh, okay, we're started. Okay, we'll mute you guys again. Good. Okay, I think it's about to open now. Okay, let's see what file we have open here. And SPSS is continuing its effort to be the most annoying piece of software in the world. Not responding. Let's give it a moment again. Hopefully it'll straighten out. Okay, I think we're catching up now. Okay, here we go. Open half the files on my computer in the meantime. Okay, so let's take a look at the file that we were talking about, if I can find it here eventually. Here we go. BMI and insulin sensitivity. I believe insulin sensitivity is not insulin, it's one of these others. See if I can't tell. What's that? Yeah, IS, glucose tolerance. I think it's IS is insulin sensitivity, not insulin level, but insulin sensitivity. Okay, so those are the two variables I'm going to be working with. Notice that insulin sensitivity and BMI are both numerical variables. So if I have two numerical variables, I'm dealing with correlation and regression. Okay, so I'm going to go back to my data view. Notice there's no coding because you're not going to put in values like 1 is equal to this or 2 is equal to that, because the number itself is the value for that particular individual in that study. So I'm going to go back to my data view. And for instance, here are our BMIs. This person, number 2, has a BMI of 23.6, and their insulin sensitivity is 0.88. Lower is better than higher. Okay, so I got that right? I think we want it to be higher. It's better than lower. But let's analyze it. We're going to see pretty easily, pretty quickly, what happens with BMI and insulin sensitivity. First thing I might do is take a look at it graphically. So I'm going to go to graphs. I'm going to go to legacy dialogues because it's just the easiest one. You can play around with chart builder and so on and so forth if you want. They're kind of like macros, like they'll walk you through the process of building a chart or a graph. But I think it's good enough to just go to legacy dialogues. We can choose scatter dot. Okay, scatter dot is just going to put a dot for each x and y value, the x and the y for BMI and insulin sensitivity. So first thing I'm going to do is correlation. Okay, so I'm going to click on scatter dot. I'm going to define what my, I'll do that again. Graphs, legacy dialogues. Unfortunately, when I'm doing it live, it can't go back and scrub back and play it over again, right? Okay, scatter dot, right? Okay, that's our what we want to draw. Simple scatter dot, define, and I'm going to tell it what my x and y axis is. I'm doing correlation. Does it matter what my x and y axis is?
Yeah.
No, it doesn't. For correlation, it doesn't, because we're not interested in causality, right? So it doesn't matter which one I put where. I'm just looking for an association between the two. When we get to regression, which one we choose as our x and y axis starts to mean something, right? Because our x axis is going to be our independent variable, the one that causes the other or predicts the other. Okay, so I'm going to go ahead. I'm not going to put in titles or anything like that. I'm just going to click OK. And if SPSS works, we should get a graph. And sure enough, we do. And what happens as BMI goes as BMI goes up? What happens to insulin sensitivity? It goes down. You don't see, it's kind of hard to see here. As insulin sensitivity goes up, BMI goes down. So people with low BMIs tend to have high insulin sensitivity. In other words, their body reacts. Insulin works the way it's supposed to work to help them metabolize sugar. Okay, now if they develop insulin resistance, their insulin sensitivity goes down. Okay, so that's bad, right? Because that's what they nowadays it seems like they call every person I know in the world is pre-diabetic and the cholesterol is too high. I don't know if you've noticed that. If you're over 30, you're pre-diabetic. You walk into a doctor's office, oh, you're pre-diabetic and your cholesterol is too high. They have like the limit now, I think it's 0 on everything. I was just reading a study recently that they're talking about. The most recent study suggests that given the new guidelines that they're going to issue, that it's likely that they're going to have like 50% of the population that's over 40 or something like that, or over 50 is going to be on statins. So I mean that. Well, yeah, there you go. Exactly. So, but yeah, but half of those are now, there's generics now for a lot of those, right? So, I think I was just reading there's a new one. I'm not sure it's a statin or some other drug that supposedly makes your LDL levels like negative numbers practically. It's like they disappeared almost nothing or something like that. So there is some new patent. Yeah, there's always going to be one that's going to be not available as a generic for some years. At any rate, so I could actually redo this again if I wanted to. Graph, legacy dialogues, and scatter dot. And if I don't feel comfortable with the way that this got laid out, I could say, oh, let me reverse these axes. Put BMI on the x-axis and put insulin sensitivity on the y-axis. Kind of the way I might look at it is a regression if I think there might be some causality. Let me run this again. And what do I get? I get as BMI goes up, insulin sensitivity goes down. I get the same thing, no matter what I did with the with my how I arranged my axes, right? I get the same relationship. Okay, so we're not so when we're talking about correlation, we're not so concerned about that. Okay, so now let's analyze this. So I'm going to go up to Analyze, and sure enough, there are two selections here under Analyze for correlate and for regression. Am I recording this? I don't think I turned on recording, did I? Yes, I did. I did. Good. Okay. Miracle. Okay, so at any rate, let's go to Analyze, except we'll go first to correlation. Now, which of these do you think we're going to choose? Pretty clear it's going to be bivariate. There's two variables. So you're almost always, for our purposes, you're going to be working with bivariate correlations. Okay, and where the variable is going to be BMI and insulin sensitivity. We could also do age if we wanted to, right? That might be another choice, age and insulin sensitivity. Okay, so now notice it's just going into a column here. It doesn't ask me to predict which one is the dependent or independent variable, and mostly it's doing that because for correlation it doesn't matter. I'll click OK, and let's see what we wind up with. Now, the significance, the significance is pretty good. It's less than 0.05, so we feel that we have a statistically significant correlation. Now, is the correlation beyond statistically significant? Is it clinically significant? Does it have any meaning? Let's see how strong that correlation is. And here's what our correlation, our Pearson's correlation, or that value R is equal to, negative 0.548. Okay, so how does that sound, negative 0.548? Not bad. It's a pretty good correlation, right? Certainly closer to 1 than it is to 0. So it looks like we have a decent correlation between BMI and insulin sensitivity. And even just looking at it, we can see that it appears to be definitely, it really does appear to be a significant correlation, a meaningful correlation, because we can see that downward slope. Now, if I would draw a line here to match this, then I would say to myself, you know, a lot of these values are going to be far away from that line. That's why my value is 0.548, not 0.95, right? It's the distance from that line. Matter of fact, if I double click in here, I can go up to one of these and ask it to add a fit line. Okay. There it is. It drew that line for me. And it cheated also. It calculated the regression for me also. I didn't want it to do that, right? But it did it for me anyway. Okay, so that is, see, notice how this fits. These points are pretty far away from that line. That line balances the values above and the values below, but the numbers, it gives you the general slope, and it's the general relationship between BMI and insulin sensitivity. But it's hard. You can see, because the individual values are so different, it's going to be hard to use that to really, for any individual, to predict it as well as if we had seen all these dots very close to this line. Then it would have been a better predictor, and it would have bigger, higher R value. Okay, we're going to come across something really interesting when that's concerned also. Okay, let me see if I can't get this out of the way.
How does all these values change with n?
I'm not so concerned about n right now. I'm more concerned about how well it fits this line. Okay, obviously, the more values you have, the more likely you are to get a statistically significant result, for significance to be less than 0.05. Right, but that's not going to affect the way the lines are scattered, because that really probably won't change much whether you have a lot of values or little values. They're still going to be kind of, scattered away from that line. They're going to vary from that line basically the same way. Okay, so now let's take a look at this idea of regression. Can we give this line a formula so that we can, if you tell me somebody's BMI, I can predict what his insulin sensitivity is going to be? Okay, and that's what we're after here. So I'm going to go to Analyze, Regression, and I'm going to go to many choices here. I'm going to go to linear regression, because we're assuming that this is a straight line relationship. Why are we assuming that? Because this is pH 750, and if we didn't assume that, we'd be here for the next 3 years, like, let alone for the next week and a half. Because regression and correlation, if you're a stat major, or maybe even if you're an epi major, you may wind up taking specific courses just on correlation regression. And multiple regression and logistic regression, and so on and so forth. It's a really comprehensive topic, important topic, right? So we're going to stick with linear regression so that we get an understanding of basically how regression works. So now notice I don't have a single box to move these variables into. I have two boxes, right? One is the dependent, and the other one is the independent variable. The predictors and the value that we're trying to predict is the dependent variable, y and x. Notice the box for x is big. We can have more than one x, more than one variable as a predictor. That's where we start talking about multiple regression. We can move several x's in here to see if we get a better fit a better prediction of what y is than if we have a single one in here. So what is my independent variable in this particular case? What do you guys think online? Which one of these is the independent variable? BMI, good, right? Everybody agree with that? BMI? Yes, Carol. I like the fact that you guys can kibitz back where you know each other, so you know who's answering this stuff online. Okay, so BMI. So what's our dependent variable in this case? It's going to be our insulin sensitivity. I'm going to put that over there. Okay, so now I am going to go ahead and continue. I'm going to click continue. If you want, you can go into these buttons and you'll see the values. It's going to predict our regression coefficient, and it could do some other values as well, but we're not going to worry about those for now. Plot. I'm not going to bother with plot. We already did a scatter plot. I'm going to click OK. Okay, and here is our results. So our significance is less than 0.01 for our regression. It analyzes the residuals. The way that the residuals are dispersed. If there's any pattern in terms of what those residuals are, like they're bigger at the high numbers or low numbers, that's of concern for us. We'll talk about that in a little while. So now, right now, I'm most interested in these coefficients and in this column B, because this is going to represent the formula for my line of regression. So my y-intercept is minus 1.5. My slope for my value of x, BMI is x in this case, is minus 0.043. So I'm going to throw on my graphics tablet here. Oh, I don't have it, unfortunately. I'm going to have to scribble with my finger or something. Open the notebook. Okay. I'm just going to. Okay, so basically, what we've predicted here, and you're gonna have to tolerate my scribbling with my finger. I wasn't expecting to use the graphics tablet tonight. So our formula is going to be y is equal to a plus bx. Okay, in our case, that's going to be our y is going to be our dependent variable, which is going to be, in our case, is going to be insulin sensitivity, is going to be equal to a, which is 1.582. That's, I'm going to call it 1.6 for our purposes. That's our y-intercept. That's the place where you're going to cross the y-axis. Let me just show you that momentarily. If you look at BMI down here, right, it doesn't really go to zero, does it? In other words, we would have to continue this graph out to the left here quite a distance. And as we're going to the left, this line would still be going up. The place where it crosses the point where x is equal to 0, the y-axis, that's going to be 1.5. And you can kind of predict that, right? You can kind of see that going up, and then at the point where it's going to cross the line, it's going to be 1.5. That's your y-intercept. Okay, and then the slope, once you know it's going to go through that point, you can predict the shape, the direct where that line is going by its slope, right? That defines the line completely. Okay, so at any rate, it's equal to 1.6 plus, negative 0.04, I'm going to round it off, times the value of BMI. Okay, so now let's take a person whose BMI, I'm going to put 3 in here, 0.043. Let's take a person whose BMI is 25. Actually, let's take 30. Let's say their BMI is 30. Let's use this to predict what their insulin sensitivity might be. So what do we wind up with for insulin sensitivity if we start off with assumption that their BMI, or we measure their BMI and it's 30? What would their insulin sensitivity be equal to? Okay, let's get our calculators out. You guys at home, you got calculators? If you're not reclining and having a cocktail and stuff like that, take out your calculator and actually give this a try. So 0.043 times 30 is equal to 1.29. It's actually negative, right? So I'm gonna switch signs on that. Negative 1.29 plus 1.6 is equal to 0.31. We predict that you're going to have an insulin sensitivity of 0.31. Okay, so let's see if we see anybody on our graph that might match that. It's pretty close to that. Here's 30. Oh, I think I made a mistake here. Negative 0.43. That was, I'm sorry.
It was 0.3. Is that what you're checking?
Yeah. Did I get a negative number?
1.29,
That doesn't look right. 1.52, negative 0.43. So 30 times negative 0.43 and the plus 0.31. And what did I get here? Oh, okay. Here's an insulin sensitivity of 30. And if I go across, that's what I would have predicted, right? I would have predicted something around 0.31. The BMI is of a person that's 30. That line indicates that we should expect that their BMI is going to be about 0.31, about there. Let's take a look at people that are close to that. Well, here's a person that's almost exactly has a BMI of 30. And what is his insulin sensitivity? It's about 0.22 or so. So that person, this line does not predict that person BMI perfectly, right? So that's a little bit of a problem. We want something that's a good predictor. Okay, well, one of the things that we calculated while we were going through here is we calculated R. Remember R? We calculated the Pearson's correlation coefficient. It came out to be 0.58, right? Well, one of the things that happened when we calculated when we calculated regression, the regression analysis, when we did regression analysis, is it took that value of R and squared it and made it and that's 0.548 times 0.548 is 0.301 R squared. The reason why that's relevant to us is because in general, that R square represents the amount that a change in the independent variable is a predictor of the value of the dependent variable. In other words, 30% of the change in insulin sensitivity can be accounted for by by a change in BMI. Well, that's not very good, right? That's pretty good, but it's not very good. 70% of the change is due to some other factor that we ignored. That's why we might be interested in multiple regression. What are those other factors? Maybe age is part of that. Maybe if we include age and BMI to be a better predictor, age and BMI and exercise level are better for that, even better predictor and so on and so forth. So R squared gives you an idea of how much of the variability in your independent variable and your dependent variable is due to your independent variable. Okay, how good a predictor it is. Now, one of the other things you might do here is that if we go back into our analysis, analyze descriptive, regression, right, and linear. If I go back in there, there's also a button here called save, and I'm going to click on that. And when we go into save, we can tell it that we want it to tell us the predicted values. In other words, use that formula, apply it, and show us what the predicted values would be for insulin sensitivity. And also, give me the residuals. Give me the difference between what was predicted and what would have been predicted and the actual value for each person. And then standardize those as well. So I'm going to click continue, and we're going to see what happened, see what the effect of clicking those three buttons are. I'm going to click OK. Okay, all right. So I don't see any change here except for that I get some statistics about residuals and stuff like that. So, but I'm going to go here back to our data view. And our data view now has more columns than it had before. Okay, for instance, it has a column that says predicted. In other words, let me see if I can't find. This person's insulin sensitivity was 0.97. The predicted value based on that formula would have been 0.79. The difference is my residual. So that's my residual. My insulin sensitivity here is 0.88 for this person. Based on my formula, that should have been 0.5. I would have predicted 0.55. So you can see that there's difference. And these predicted values and these residuals tell you how far from the real values that you would have predicted based on what you found for your residuals. Now, the other thing that we might be interested in, and this is why we kind of did this standardization, these are the z-scores for how far each one of these values are from the predicted values. If I can click I can do another graph here, scatter dot, and I can ask it to give me a distribution of the, let's see, the residuals, let's say, for instance. Let's see, unstandardized. If I hover over it a moment, it'll come up. I'm not going to get into that because I'm just going to confuse you at this stage. So, and we're getting pretty late. One of the things that we're concerned about is that the differences that we see, that we don't see that these residual values, the differences between what the line predicts and these actual values, we don't see that these points are all close to the line at one end and far away from the line at the other end. We expect them to be randomly distributed. If they're not randomly distributed, it starts to make us think there's something wrong with our regression. So in this case, it looks like the variability, whether we're in the middle or at the end, it looks like it really doesn't make much difference in terms of how far away these values are from that line. So it looks like the residuals are randomly distributed, which is a good thing. Okay, so now what is this and why is this important to us? Well, if we have numerical variables, you can demonstrate to me, number one, is there a correlation, an association between variable A and variable B? And then not only that, but you can tell me how good you can then do a regression analysis and tell me how good a predictor that one variable is of the other variable. And that may be important to us for a couple of reasons. Number one, to see how well it predicts the other also tells you whether or not there's other influences. Like in this case, 70% of the differences came from something else than just BMI. Okay, age, exercise level, whatever, diet, whatever.
So you would never say cause for regression, it would be a predictor.
Yeah, I think predictor is a better, word than cause, right? I think that might be a better way to term it. Okay, so if any of you guys are going to work on numerical variables, and there are some, I'm going to open up we're going to move on now to our project discussion, and there are some that may be of some interest to us, and